Thanks, everyone. As you said, I'm the platform security strategist at Adobe. I work on their application security engineering team. And I do a lot of different things there as sort of a lead researcher. The thing that's most relevant to this talk is I assist in incident response and secure product lifecycle work for Flash Player. So whenever a vulnerability for Flash Player comes in, I'm usually one of the first guys taking it apart, creating a safe version of it for the devs to work with, and then analyzing it and trying to figure out what we can do proactively in order to be able to prevent future exploits of the same kind in the platform. So I'm going to talk a little bit about what I mean by advanced persistent response, give you a little bit of background on what Flash Player has seen in terms of attacks over the last 3.5 years or so. I'm going to talk about how you analyze the threat. Any sort of response plan should first start by getting a sense of where you are and who's attacking you and what you need to deal with. And then I'll talk about how you can find resources to deal with the threat and the actual execution and planning for the response plan. So the title of my talk is obviously sort of a play on advanced persistent threat. I think most of you guys have heard APT before. It's one of the most overused terms in our industry. Websites get one cross-site scripting attack and suddenly they're the victim of an APT. So if I'm going to use this term, and I'm going to try to use it, if I'm going to use this term and try and use it legitimately, I basically have to be able to prove two things to you guys. I have to prove that the attacks are actually advanced, that there is actually some skill behind what they're doing, that they're not just opening the shellcoder's handbook and starting at page 1. And then I have to prove that they're persistent. And proving that they're persistent is probably the easier of the two. What this graph here shows is the attacks that we've seen against Flash Player over the last 3 years, basically since about 2009. I include zero-day attacks, and I also include 2 instances of attacks that occurred after we released a patch, but we're still within about the first 30 days. And I include those because if it's within about 30 days of us releasing the patch, I either have a suspicion that the person had the vulnerability before we released the patch and they were able to turn around so quickly because they'd already started on it, or they're just at a position where they're able to quickly turn these around. And part of what's going to be important about this graph throughout the talk is that the attacks that we've seen against Flash Player have changed over time. They're not using the same technique over and over and over again, that they're actually changing their strategies, that they're having to actually deal with the things that we are doing. And one of the measurements of a good response plan is, can you make your adversary change their MO? Can you make them change what they're doing to deal with you guys, rather than you just constantly be in the position of responding to them? Can you make them respond to you? So originally, Flash Player attacks in 2009 were mostly focused on Swift and PDFs. The security community the hacking community was focused mostly on using PDF attacks, and they had switched over to Swift just because they had figured out that they could put a Swift inside of a PDF, and it extended what they were able to do with PDF attacks. Then they quit doing PDF attacks and they started to switch to Office documents, and you would see Swifts in Excel spreadsheets and Office documents as a way to do spear phishing attacks to get into the targets that they wanted to get into. And those went on for a little while. Then they had to change to doing universal cross-site scripting attacks, which is actually a very big change because with universal cross-site scripting, you can't just fuzz and find a universal cross-site scripting attack in a Flash platform. You have to actually study the language. You have to know what loaders and calls are used for cross-domain loading, and then find a vulnerability in the same origin enforcement for that. So that actually showed them starting to learn the language, starting to change how they were going after people when Office documents. And then this year has been a little bit random. This year it's been a little bit all over the map. We actually had one attack which involved the RTMP protocol. So in order to successfully do that attack, the hackers had to actually set up an RTMP server that could respond to an RTMP handshake and then deliver the payload to Flash Player and cause the crash. And that's a much higher bar than just putting a malicious Swift up on the web or sending a document. You have to actually have a server that's in your control that can respond to RTMP requests and send a malicious packet. So that's not something you would see with the black hole exploit kit where they just want to be able to plop a file in the file system of a web server and move on. And we've also seen a couple of attacks where it's come out after we issued the patch, which One of them in particular is based on the code is actually particularly hasty. So this year has been a little bit random in terms of what we've seen, where they've been a little bit more all over the map. But I'm going to be referring back to this as we go throughout the talk in terms of what we've seen. For now, I think this is enough to show that it's persistent. I've got 15 different attacks over about three and a half year period against Flash Player. So an advanced persistent response is basically how do you deal with this problem? How do you deal with somebody who's going to be that persistent and target you year after year, doing different methods, doing different attacks? How can you inhibit them? Can you slow them down? Are you able to, what can you do in terms of responding to that? And what can you do as a company of Adobe's size, which is roughly about 10,000 people, to respond to these attacks? And so this is going to be what I'm going to be focusing on throughout the talk. Your first step in responding to an advanced persistent attack is doing information gathering. The attackers, if they are advanced and they are persistent, they're going to learn a lot about you. They're going to learn about when your labs releases go up, they're going to be watching your betas, they're going to be reversing your code, they're going to disassemble every single byte that you put out. So it seems only logical that you take a little bit of time to learn about them, right? And to understand what are their motivations, what are they trying to get at, and what are they likely to use as far as targeting the platform. So you want to know who your adversary is. Who are they and why are they upset? For instance, the reason why Sony got attacked a while back was very different than the reason why a defense contractor gets attacked, right? Sony was getting attacked over hacktivists who were upset that GeoHot was being targeted in a lawsuit for breaking the key. Whereas a defense contractor, they're nation states and they're going to be a little bit different. And the way that those two groups behave is going to be a little bit different. Anonymous would actually tell Sony when they were coming because they knew Sony couldn't stop them, right? They would go online, they do YouTube videos, and they were very public about what they were doing. If you're the type of person that's a nation state and you're targeting a defense contractor, you're likely to be a little bit more quiet about what you're doing and leave a bit fewer breadcrumbs. Right? If you saw Grux talk a while back, it was basically a 1-hour presentation about the first rule of Exploit Club is you don't talk about Exploit Club, right? So you want to know why they're targeting you. It'll give you information about where you may be able to look for stuff online. Sometimes the reasons why they're being attacked will change over time. For instance, Sony started out being attacked based on hacktivism. After a while, it just sort of seemed like a dog pile. But sometimes the reasons why you're being attacked will change over time, and you need to be monitoring that. You need to be watching for that. And to give you one example, in Adobe's case, there was a guy on Twitter who would actually post online information about his exploits before they actually showed up in the wild. So his account name was Yonge1975. That's not actually his photo. It was a fake account. But he would post stuff about, in my next Flash Zero Day, I'm going to include a memorial to the victims of the tsunami. And he would actually talk to us. Like the second one from the bottom, you probably can't read it, but he's, hey, Adobe Security, when's Flash Player 10U coming out, right? So he would actually talk to us, right? He would actually show up on Twitter. So this was him giving a little bit of details about what was going to be in CV 2011-069. He then also posted what you would see in the crash dump for CV 2011-0611. And it didn't necessarily help me. This wasn't enough information for me to stop the attack, but at least I knew that maybe I should get all my errands done soon because I'm going to have a busy week next week. Or for a more practical purpose for a business, if you have a ship schedule, you might want to slow down the ship until you figure out what it is. And he just sort of kept doing this until Brian Krebs wrote an article about it. And I think at that time, the people he was selling to probably noticed that he was being a little too talkative, and he shut up after that. But you can go out and you can find this information. Obviously, if you're using human means to go and find this information, you're going to have some false positives. There's actually one guy on Twitter who posts once every 6 hours that there's a Flash Player 0 day, and it's just been in a loop for like the last 2 years or so. So you have to wean out the false positives, but there is useful information to be found out there if you're willing to take the time to go for it and look for it. and make sure it's there. The second thing you can do is you can do a technical analysis of them, right? And this is probably more interesting to you guys in the human aspect. But you can look at what their sources are, you can look at what they're targeting, and you can look at what their relative skill level is when they're attacking you. So, for instance, the attacks that we saw in early 2009, a lot of the Swifts that were used in the 0 days all came from the same website. So it's fairly, and the website was flashandmath.com. They made Swifts that did complex math compositing to create interesting visuals, right? So Flash Player, it was a good site to use because Flash Player was doing a lot of number crunching, a lot of places for integer overflows because it was doing complex stuff. And you see 1 0 day that comes from this website, okay. You see 2 0 days from that website. Well, maybe the guy just sort of spired this website, pulled down all the Swifts from that site, and just ran fuzzer against all of them, right? And if you know that, and if you can start to see this pattern, then you can pull down all the Swifts from that site, and you can start running the fuzzers against them, and see if you can catch up to where this guy's at in terms of finding vulnerabilities from this site. Another thing you can take a look at is who they're targeting, right? In Flash Player's instance, in the case of Flash Player, almost all the attacks that we see are attacking government contractors. They're very targeted spear phishing style attacks where they're going after something that's critical to infrastructure, like the RSA attack, or they'll go after defense contractors. We're not really used all that much in terms of like general web attacks, where if you're just generally surfing the web, you'll come across a Flash 0 day hosted on the website. Those are fairly infrequent. And what this means is that we have a different response strategy, right? Like in terms of being able to who we need to protect. For instance, if you look at Java, Java is sort of a favor of the black hole WebKit, and part of the reason is because people don't get updates. Therefore, they can go and they can take a Java 0 day and use it for 2 months, 3 months, for very long periods of time, and it'll still be successful against a large portion of the populace in terms of installing fake AV or whatever their goal is. But with Flash Player, we haven't necessarily seen that as much. We have been used in the black hole exploit kit, but it's not. We're usually not the first one that they choose, and there's only a couple of exploits for Flash inside those types of exploit kits. Far more often, if we're responding to a 0 day, it's because of a targeted attack, where the contractor or whoever the target was contact us directly. Another thing you can do in terms of technical analysis is you can look at the payloads that the Swifts are dropping. Symantec does this a lot, and Symantec publishes several reports where they're not necessarily concerned about what was wrong with Flash Player that caused the crash, or even whether or not they used a heap spray, as much as they are concerned about what got dropped by the payload. And so they'll go and they'll tie a series of attacks together based on the fact that the payload always goes back to the same command and control botnet, right? And that sort of tells them, well, it's probably all the same group because they're all using the same botnet. And so one of the papers that they wrote on this was a paper on an attack called Sycopot, where they came to the conclusion that the attackers were organized and that they were doing persistent long-running campaigns. And one of the things that looking at payload analysis allows you to determine is, in this case, they were technology agnostic as far as how they delivered their 0 day. If they had an IE, they would use IE, they would use Word, they would use Flash, they would use PDF. They would use whatever technology was convenient for their how they wanted to deliver the attack. But it was always to drop the same payload. It was always so that they could get back to the same botnet. So it wasn't that a specific individual is targeting a specific technology over and over and over again. Some of these advanced attackers are they're technology agnostic. They'll use whatever 0 day they have that fits their needs at that time. And that was one of the things that Symantec came to the conclusion of with at least this group of attackers, is that they were being technology agnostic, attacking multiple development platforms or multiple software platforms to deliver the same payload. And the other thing you need to be able to monitor, and part of the reason why you need to be able to do this sort of intelligence on people, is there will be changes in the field. Like I said when I was showing you the graph at the very beginning of this presentation, they will change their tactics. They will learn, they will adapt, they will get better over time. And you need to be watching for that because you're going to need to change, you're going to need to adapt, you're going to need to get better over time. So, and that may change the strategy that you have in terms of what security features you're going to prioritize, where you're going to focus on your fuzzing, where you're going to prioritize your manpower. You need to watch for those changes in the field. And I said for the most part, Flash hasn't been used in exploit kits, but for a small period of time in 2001, or I'm sorry, in 2011, we were used in being used somewhat heavily in exploit kits, and they were all using attacks that were 2 months old, right? They were targeting people who had out-of-date software by at least 2 months. And so what that meant was, before out on the internet, you would see very limited instances of these attacks, a Flash player. But as soon as we got put into an exploit kit, the numbers of attacks against end users and people in the wild jumped dramatically. So this was sort of a significant change. And it changes how many people are going to be affected by the flaws in your software. It's going to change what the internet community is going to have to do in order to protect themselves. Now, that said, if your strategy is working, everything's relative and everything's going to change. So in this graph from Microsoft's most recent Software Intelligence report, Flash Player is at the very bottom, where the brown line that sort of peaked in early 2011 and then immediately died back down. We were able to sort of get it back under control. But one of the things you also sometimes notice is if you have attackers who are attacking multiple platforms and jumping around in the field, as one technology goes down, the attacks in other technologies go up. Because they're not going to slow down the number of attacks they do, they're just going to change which technologies they're using. So like you may have noticed, and I don't have math to actually prove this because there hasn't been a long enough period for me to have a conclusive data set, but you may have noticed like Java 0 days have been going back up and IE 0 days have started to go back up, right? They're switching around because one thing's getting hard, so they're switching back over to another technology. And the last thing you can do in terms of technical analysis, and this one's also very important, is attackers will gain skill with practice, right? A lot of times when you look at security reports about a 0 day, it's very isolated. It's about that one 0 day, here's a description of this single bug. But if you have an advanced attack and it's actually going over time, you can actually learn things if you look at the attacks consistently over a period of time, over the course of a couple of years. Because you will see the hackers get better at what they do and how they structure attacks against you. So if I look at an attack from 2009, like 1862, it was a very, very simple attack. It was, they went and they got a Swift from flashmath.com. They did single bit flipping. They flipped the right bit. It caused a crash. They created a whole second Swift to be able to do the heap spray. And then they sort of embedded both of them into a PDF for the attack. It was sort of clumsy but effective. Flash was mostly a means to the end in terms of the design of this. As we moved into 2010, they started to actually do more ActionScript programming. They started to get better where they figured out how they can embed the crashing Swift inside of a parent Swift. So they can have the heap spray and the crash all in the same Swift. A little bit more elegant, doesn't require 2 files. You can do it in a single shot. Another advancement in 2010 is we could actually see them starting to use new research in attacks. So at Black Hat DC, Dionysus Blazikas presented a JIT spray technique, a very specific JIT spray technique where you could actually figure out memory addresses and leak information. And it was a really good paper in terms of what he did in terms of research. And that was February 2010 when he published that at Black Hat DC. By roughly September 2010, I actually saw the code from his paper starting to show up in exploits. Now, fortunately for Adobe, we'd actually patched the issue, so the attack didn't work. If you looked at the code for that attack, they basically copied and pasted the stuff from Dionysus's paper directly in there. It didn't work, and then they just kept coding and created their own heap spray after that. They didn't go back and delete the code that didn't work. But I can actually see them starting to incorporate research, right? So they're following what's going on in the security community. They're trying new things. They're learning in terms of what they can and can't do. By 2011, we started to see them do things like dynamically passing information into Swifts. They figured out different ways of using flash files to pass URLs and other information into the Swift dynamically. That way they didn't have to create a new variant every time they wanted to switch something up or switch the payload. They figured out how to dynamically pass that information in. They were also starting to target specific versions. So if you looked at the ActionScript code, you would see them doing version detection because they're memory addresses were tuned to the very specific version of Flash Player. And this was, the code here was actually from an exploit targeting 10.3.181.23. So they already had the last 3 releases figured out where they needed to jump, where the ROP gadgets were, and they were dynamically adjusting the code based on which Flash version they were in. We also started seeing return-oriented programming where they started to use ROP gadgets from inside Flash Player. And so it was very clear that they had figured out the lay of the land in terms of Flash Player binary, where things are, how to deal with differences in different versions. And it was much more, the code started to get very much more eloquent in terms of the exploits they were doing, in terms of some of them would even bypass ASLR and DEP. Because they were starting to use info leaks, things like that. So they clearly learned the platform by this time. Like I said, there was also a number of universal cross-site scripting attacks. And to find a universal cross-site scripting attack in the Flash platform, you actually have to really play with the code. You can't just fuzz it. You have to do manual code testing to try different loaders, to try loading things across domains, to write event handlers and see if there's a missing same origin policy check in an event handler. So this was a completely different MO. This wasn't some guy who was sitting there with a fuzzer. This is someone who's learning the ActionScript language inside and out and looking for same origin bypasses in the language itself. So you can just start to see them getting more and more sophisticated. And like I said, by the time it got to 2012, now they're starting to do protocol-based attacks, or they're not limiting themselves to the file format. They're doing streaming. We're seeing faster deployments. There are a couple of cases where I think they were able to turn the attacks around fairly quickly. And we also started being used as tools in other platforms. So one of the research reports that Symantec published was regarding the Elderwood gang. This was the paper that they wrote that discussed the watering hole attack, if you remember seeing that going by on Twitter. But one of the things that they talked about was that Swifts were used in IE attacks, not to cause the actual crash. The crash was a problem with IE XML parsing, or it was the actual bug in IE. They were just using us to set up the memory. So they'd done all this research to create, figure out how to do memory layouts and stuff like that in Flash. So if they couldn't attack Flash, well, they could still use some of that knowledge to attack IE. And so they started using Swift as not necessarily the cause of the crash, but as a way of doing memory layouts. So they're starting to expand the knowledge between technology products again. So overall, you can just start to see them gradually getting better and better at what they do, that they're learning the platform. Each attack's more sophisticated than the next. They're doing ROP programming. They're doing ROP gadgets. They're looking at the languages. They're understanding the holes in the language, using info leaks to bypass ASLR and DEP. So over the last couple of years, I can just sit there and watch them get better and better at what they do. So I know that from the response perspective, what we have to do is get equally better. We have to get better and better in terms of stopping them. The question is how do you do that, right? If you have somebody that's going to be this persistent, you have somebody that has these capabilities of learning and adapting for your platform, how are you going to resource that response plan? You're going to basically need more time, more money, more hardware, more people, all the problems that every business has when they're trying to scale something fairly quickly. And so you're going to need to be able to figure out, how do I manage the resources I have? How am I going to scale quickly to be able to defend against this type of a threat? And so one of the first reactions a business will have when they're starting to get attacked is, it's a security bug, it goes to the security engineers. The security engineers will fix the security bug because they're the security guys. And that's actually not the model you want to go with. What you need your security engineers doing is working on the big picture projects, on the holistic mitigations, on the strategies that will actually have an exponential effect in terms of protecting your platform, not fixing every single length check on the string copy throughout your entire code. You want to be able to have your developers do the bug fixing, and you want to have your engineers work on the strategic stuff. And this is the same thing if you're being attacked from a web perspective as well. You want your security engineers working on the templates and the common modules that will mitigate cross-site scripting. And then you want to have the developers deal with the actual deployment of those modules on a line-by-line basis and make sure the developers are in charge of deploying it. But the security engineers are doing the big picture thinking. They're focusing on what they can do best, which is holistic security mitigations. Of course, if you're going to hand all this stuff off to the developers to fix, one of the problems you're going to deal with is training. How are you going to get them to be able to fix these bugs? And training seems like sort of one of those boring things. Yes, everybody should go through training, sort of those mundane tasks. But it really does have an exponential effect in terms of what you're able to do. So within Adobe, we have different security training levels. You can get belt certifications. White belt, you've taken like Hello World security training, green belt, brown belt, black belt. And so by getting a white belt certification, that means you can go up to any developer and be able to say the word buffer overflow and they kind of know what you mean. Right? You're not starting the same conversation over and over with teams. But in terms of finding resources, one of the things that we found interesting from training as well is that for our brown belt projects, or for our brown belt level, you can't just take a quiz and prove you know this stuff and get a certificate. To get a brown belt at Adobe in the security training program, you have to actually do a project which demonstrates that you can actually apply the knowledge that you learned. That you can do more than just fake your way through a multiple choice test. Right? And with the brown belt projects, we don't limit the brown belt project to being a project within that development team. So let's say you're a developer in a different product. And maybe that product's kind of boring. It doesn't have a whole lot of security problems or security concerns because it's like an internal app or something like that. But you're a smart guy and you're a good guy and you're good at what you do and you want to learn security. You could actually do a brown belt project that would benefit the Flash Player team, and then we would give you the certificate for doing that and give you credit for doing that work if you donated some of your free hours. And this had a lot of benefits. For the devs, their certificates are important because it's a measurable thing that they can go to their managers and say, I did better this year. Here's a piece of paper showing that I've grown as an engineer, right? Every time you go to your boss to say you want a raise, why did you deserve a raise? Well, I worked hard, right? Well, everybody worked hard, right? The piece of paper is sometimes important to them just because they can actually physically show their boss something. Like, I'm certifiably one level better than I was last year. And for us, it was important because it allowed us to be able to pull little bits of resources throughout the company as we delved out these projects to get people contributing to helping stomp this down. So it was a way of actually unofficially getting resources from other product teams and other product groups to help with this problem. And the training program was also good because it helped us, like, we're a fairly large company, we're a global company, we have engineers in Romania, China, India, everywhere. The training program, if you watch who signed up and who did the trainings, we were able to find people that actually had a strong interest in security because they would usually be the first to sign up and do the training and they pass it the same day. And it's like, okay, this is somebody who's actually has an interest. We should make an effort to actually reach out to that person. And it turned out to be a good way for us to find people with security interests throughout the company rather than just sort of like having a general security interest mailing list or hoping that they can find you. So training was an important thing. And from a measurable standpoint, one of the things we noticed was that as we rolled out the training to more and more of the company, our zero-day response team improved over time. Because you just didn't have those hello world discussions with people over and over again. We have to do this quick. There's a 0 day. What's a 0 day, right? As you were able to spread security knowledge throughout the organization, the response time dropped significantly. And trying to get it through the entire organization is sometimes important because in any large software company, there's going to be components which aren't made by that particular product team. There are libraries that are sort of general core libraries that are shared throughout a bunch of the company's products. And they're going to be a different team than the actual product team. And so if the fuzzing creates a vulnerability in that, then you have to go to a completely different product team and be able to explain to them, hey, there's a bug in your software. We need you to help fix it. And you need to be able to do that rather quickly without having to go through the what's a 0 day discussion with them. So that's sort of important. Another thing that we've used a lot within Adobe is we actually made friends. We tried to partner with people in the industry, right? The training stuff's good. It'll help you get more resources internally. If you're lucky, you're able to free up some budget to help get more consultants and things like that. But again, if you want to be able to exponentially scale your response, you have to be able to learn how to make friends in the industry and work with people that you wouldn't necessarily normally work with, or where the business would normally be a little bit shy because maybe there's an IP issue or something along those instances. And so through the response process over the last couple of years, we've tried to reach out to a bunch of different groups. Obviously, you work with researchers. You want to have a good relationship with researchers. They will help you find bugs and be sort of an extension of your bug finding projects. They also come up with interesting research, like Dionysus's research, which was something that we probably wouldn't have easily found internally. We've used business partners a lot. A lot of people know we're integrated with Google Chrome. The Google Chrome team's done a lot of fuzzing on Flash Player. They've helped out with the security work. We've worked with them on the Pepper integration, the recent Pepper sandbox. We're also integrating into IE10 on Windows 8, which means we've had to work with Microsoft and work with Microsoft's security team. So we had to be able to, sort of open the kimono a little bit and work fairly openly with our business partners to, so that their security teams could also help us find bugs. And, since they're much larger organizations and they have sometimes better tools than what we have. We've worked with defensive software companies. We're part of the Microsoft Active Protection Program. That's important in terms of if you can't stop a vulnerability, the defensive companies are usually the ones that can try and block it while the customer doesn't have a patch. So being able to make sure that they have signatures and the capability to help detect these bugs is important, because if you can't stop the 0-day from occurring, you can at least stop the number of people it'll affect by working with software companies. We've worked with victims of the attacks, and that's sometimes hard because they're not necessarily happy with you if they're the victim of the attack. But it's an important thing for us to be able to reach out and talk to them, right? We don't want, if a defense contractor gets hit by one of these APT threats, chances are they're going to be hit again, and they're going to be hit again. And you don't want them like calling your first-year tech support and having first-year tech support ask, did you try to reboot the machine, right? You need to make sure that the people who are being attacked through your software have a way of contacting you, and then they can do it rapidly so that you could work on a response in case they get hit twice by the same group. We've also worked with tool vendors to increase the number of tools that can analyze SWIFTs, that can be able to parse SWIFTs, to be able to find vulnerabilities in SWIFTs. Sometimes we add, because we have so many 0-day attacks against us, we're a really good metric for identifying false negatives, because there's provably an exploit there and the tool provably didn't find it. So we can work with tool vendors to be able to say, hey, we have some provable false negatives in your product. How can we work so that you guys don't miss these bugs or overlook these bugs again in the future? All right, so now we actually get to planning the response, right? We've analyzed the target. We know these guys are advanced. We know they're learning our platforms. We know they're switching stuff around. We have as many resources as we think we can get. So what do we actually do for a response, right? And there's always the SDL, the Security Development Lifecycle, the SPLC. But that's never going to be enough, right? The SPLCs are designed to gradually improve software security over time in a measured, sort of tempered way that slowly ramps up. If you're being attacked by an APT, you need to be able to move faster than what the traditional software development life cycles can be able to do. This is good. It'll get security will be better, but you're not going to be improving security at the rate that you need to in order to be able to deal with these threats. And basically, your response plan is going to have two major goals. One is you want to increase the difficulty of exploitation. You're not going to necessarily find every bug in your product within the first year of doing security testing, but you may be able to make it harder for them to actually turn the bug into an exploit. The second thing is you want to be able to limit the window of opportunity for use. One of the things that you want to make sure that you do is to ensure that if you can't stop the 0-day from happening, you can at least minimize the number of people that have been affected by it. And so that they only have a very small window and it doesn't end up in like the black hole exploit kit where it's used for years and years against people. So those are your two primary goals. And so when you say those goals and you look at the first one about, an immediate first instinct is we'll kill all the bugs. We're being attacked. Oh my God, quick, kill all the bugs, right? So you try to go from like fly swatting the bugs one at a time to like crop dusting and trying to kill the bugs in mass. And we did this. We've done this a couple of times. We've worked with Google twice on a large-scale fuzzing effort. I have stats around the first round, which we completed late last year. They just did another round of fuzzing, sort of corresponding with Ponium. I don't have the stats for round 2 yet because we're still fixing a couple of bugs and there's some details I need to work out. But it was along the same lines. They conveniently had 2,000 CPUs lying around. They also happen to have their own copy of the internet, so which is sort of convenient. So they went out, they downloaded 2 terabytes of Swifts off the web. And then they used a technique called corpus distillation to reduce that those number of bugs into about 20,000 files, which represented a good overview of features within Flash Player. And that took them about a week to do, and then they spent 3 weeks doing fuzzing, just basically doing simple bit flip approach. And Tavis Armandi was sort of heading it up in terms of doing the bit flipping and focusing all these servers against our player. And we got a lot out of it. They were able to give us about 400 files, which we distilled into about 80 unique cases. Typically, when they do mass fuzzing efforts, or we've done mass fuzzing efforts, there's usually like a 1:5 ratio in terms of code changes to bug files. I actually used a fuzzer to reproduce and classify the issues. So I took a fuzzer called Faux, which is distributed by CERT. I turned off the fuzzing and put it into copy mode, where it just does replays. And then I used Faux's capabilities to do the bang exploitable stack trace dump and minimization to classify and immediately determine how many of these we could reproduce. Google was doing a lot of their fuzzing on Linux. I needed to know how many of these reproduced on Windows, how many of these reproduced on Mac. Faux is a Python-based tool, so I was able to easily go through and see how many of them are easily reproducible and hand them over to dev teams. Also, if you get 400 bugs, you probably need to write a tool to auto-file them because it's a bit tedious to manually enter all of those in. And we created the Tiger team to address the issues because if you're dealing with that many files, you want to have a centralized team who's trying to focus on all of them and look at all of them to see if there are patterns, to see if there are things that you can discern from the attacks. Like, can you tell that like these group of files all deal with the same area of code and these group of files all deal with the same area of code or the same instance? And it worked pretty well. We were able to address most of the issues within 60 days. In terms of being exploitable, I created this graph just because people like graphs, showing how many were exploitable, how many were probably exploitable, how many were unknown, et cetera. And to a certain extent, this is just a reflection of Bang Exploitable's capabilities to classify different types of crashes. There are a large number of crashes which Bang Exploitable just can't classify. So you'll get a large number that are unknown just based on that. Also, if you've ever used it, you can actually run the same file through 2 times on the same machine the exact same way, and you'll get 2 different outputs depending on how it crashes. So the numbers are a little bit fuzzy because of that. Like some crashes, you run it once, it's exploitable. You run it twice, it's probably exploitable. You'll sometimes get slightly different results. But this was how it broke out in terms of the number of bugs. We had 5 exploitables, 10 probably exploitables, and a large number of unknowns. If you want to do an alternative measurement, after we did the fuzzing run, people started complaining online that we killed all their bugs, and Google was cheating with using their massive computing power to find the bugs. After the second round, we got similar complaints where someone was getting ready to file for Ponium 2, and Google killed the bug right before they were able to file. So that's one way of sort of measuring these. The lessons we learned was the corpus distillation worked. We got bugs spread across the entire code base. We eliminated some low-hanging fruit that could be found by simple bit flip fuzzing. But if you actually did the math, we did about 1 code change per 1.44 years of CPU time, right? So if you happen to have 2,000 servers lying around, so you can do this at scale, that's probably not a big issue, right? Like if you saw Ben Nagy's talk yesterday, he said how much he really liked to do things in scale. But if you want to get a little bit more out of it, one of the things that you can use is use these fuzzing bugs as hints where to focus on code review, right? This is going to show you where the somewhat shaky pieces of code are in your product. And if you have a good dev who actually has the time, because he's part of a Tiger team, to actually look at that section of code, he will clean up more than just that one line that's causing the crash, right? He'll be able to go, oh, okay, this was all written in like 2002. I'm just going to modernize this whole section a bit. And that'll actually cut out a couple of other bugs. It might stop some of the bugs that are behind the bugs, those type of issues. So if you're going to do something like this, you want to make sure that the devs have time to do more than just like add a length check, add a length check, add a null check, add a length check, add a null check. That they actually have time to look at the code and say, like, is this flaky code, or is this actually fairly decent code with just one bug? And if it is flaky code, maybe either we fix it now or we mark it as an area of looking at for later, right? Because the bugs are going to be across the entire code base, and it's a good way of finding out, like, flaky, somewhat solid. The other thing you always learn, though, is that there's always going to be one more bug to find. So this is a Twitter post from a guy at Disco, which is a sort of exploit extension. And I don't know, as far as June, I think it still worked. So even though we had done the massive Google fussing run, there were still bugs out there to be found, and people still had them. So if that's the case, if there's always going to be one more bug, what else can you do, right? Like, fuzzing is not going to get you there fast enough. There's always going to be one more bug. You're always adding new code to the product. You need to be able to step things up a little bit. So you need to look at holistic mitigations. You want to be able to look at those things that are actually going to make turning those bugs into exploits harder. And those are typically going to be more effective during attacks. The downside is that they're going to require experienced resources and longer time to develop. And that can sometimes be challenging in an organization, like a medium-sized organization, because you may not have the bandwidth to do both simultaneously, and you need to figure out the balance between finding the bugs but also working on these holistic mitigations. And the holistic mitigations have actually been proven to work. So with Reader, we had actually deployed 3 different controls, a JavaScript blacklist. We improved the updater to get the updates to end users faster, so that as soon as we had the mitigation available, it was deployed. And then there was the Reader 10 sandbox. And to give you a sense of size, the Reader 10 sandbox took us over a year of effort. There were a bunch of engineers from other teams that had to jump in and help with it, because it's a huge code base. We had 2 different external consultancies looking at it multiple times in order to be able to do it. But if you look at the attack trends, they actually worked. So when we introduced the JavaScript blacklist, people were attacking Reader. They were doing JavaScript and PDF attacks. They were doing it. We introduced the blacklist. They tried one more time with the JavaScript bug. They realized it wasn't really working. And that's when they switched to PDFs, Swifts and PDFs. Right, so rather than try to find a way around the JavaScript blacklist, they just switched their MO and tried a different technique rather than trying to get around the mitigation. And the same thing occurred when we deployed sandboxing. They were doing Swift and PDF, Swift and PDF, Swift and PDF. As soon as we launched Reader 10 Sandbox, then they started doing Swift and Microsoft Word documents. And all the attacks started to switch over from Microsoft Word documents. And since we've launched the Reader 10 Sandbox, we only had one 0-day, if I remember right, we've had one 0-day attack since the Reader Sandbox launch about 2 years ago, and that was targeting Reader 9. It was explicitly targeting Reader 9. Since we've launched the Sandbox, the attacks against PDFs have stopped. And so Flash Player is still being attacked because you can use it in Office documents. But the holistic mitigations, that year of investment for the Sandbox in Reader paid off because it just became too difficult for them to figure out how to get out of the Sandbox, so they just moved on to something else, which was easier and could keep them going. On Flash Player side, we've been doing a lot of sandboxing work too, because we're trying to reproduce the same thing, right? We're trying to just deter them from being able to break out of, use Flash Player as an attack. And for browsers, we actually have 3 different sandboxes in place. We updated Chrome from an MPAPI browser sandbox to a Pepper-based sandbox recently, within the last couple months. If you don't know MPAPI and Pepper, it's basically the way that plugins talk to the browser. So MPAPI was designed for plugins back in the day when everything was trusted and you trusted plugins, and everybody loved everyone. And with Pepper, it was a new version of plugin interface where the browser assumes the plugin is hostile. And so it's much more limited and sort of assumes that the plugin may be compromised. With Firefox, we do have an NP-API sandbox in place. We just launched that this summer. And with IE 10, we're going to be a part of advanced protected mode on Windows 8. So with IE 10, you have things like app containers. We're going to be in the IE 10 app container, which means desktop mode and Metro mode are going to be separated, that there's a broker for file read and write access with IE 10. And hopefully by having these different sandboxes, we'll have taken Flash Player, which has 90% penetration across the web, and effectively divided it into like 3 groups of 30, because they have to find a unique way out of each sandbox if they were to actually attack a browser. So, because the way to get out of the Pepper sandbox may not be the same, may not work against the NP-API sandbox of Firefox, which may not work against IE 10. So it sort of just breaks up that group. For outside the browser, with Reader 10 or greater, Flash Player doesn't run by default. So if you have Reader 10, they can't do a Swift and PDF attack because it doesn't run by default. Same thing with Office 2010 or greater. The problem that we're running into right now is that a lot of defense contractors don't update Office all that often, so there's a lot of people who are still in Office 2007. And that's part of the reason why Swift and Office documents are still popular. So if you work for a company, encourage them to update it to the latest version of Office. We've done some other minor improvements. Like I said, Flash Player is used for heap spray attacks, and we've been doing a little bit of work on trying to make it a less friendly environment for heap sprays. We had one success, and that I was able to annoy Hi-Fi, who was doing some research. We haven't completely stopped them in terms of heap spray attacks, but you just start cutting things down, whittling it down. You'll eventually get there. And the other thing that we've taken a look at is updating end users, right? This is a graph from Microsoft Security Intelligence Report 12, or the first half of 2011, sorry. And basically, the amount of time you have, or the window you have for updating end users before something goes into an exploit kit like Black Hole is about 2 months. Like if you look at this graph, the red line is when it was actually a 0-day, and then the blue line's like 1 month after the update, and then the green line's 2 months after the update. So you can see, it was used a lot until we had issued the patch, then like died down to 0 for a little bit, and then spiked up as a 0-day attack, or not as a 0-day attack, as something inside of an exploit kit. So when we were looking at improving our updaters, our window was to try to get it as minimal as possible so that we can just chop off that second part of the graph. And also, it makes it easier to get updates to feature updates and security feature improvements to people faster. And there's actually 2 ways you can improve your update goals. One is working with AV and IDS vendors, so that protections get out there faster. So if it is out there in the wild, all the AV and IDS vendors have the signatures information to be able to block these attacks. And the other was to actually get the patch to the end users. And so for getting patches to end users, we've done 4 different things. We have a background updater for Windows and Mac, so that when the background updater kicks in, you usually get updated within 24 to 48 hours. With Chrome, you're integrated with the Chrome updater. For Windows 8 and IE 10 going forward, we're actually going to be distributed through Windows Update, which will cut down the number of updaters that IT admins have to deal with. Flash Player will just be another part of a Windows Update, which means that they can streamline it. One IT admin in the back. And we've support SCUP and SMS. So like we have SMS servers, so you can hook up SMS to poll us and find out when there's an update, and SMS will message you when you get it. And those seem to have worked. And I think that the updaters are part of the reason why we don't at least stay popular inside the exploit kits, because the exploit kits need that window to turn the 0-day into an actual web attack for their platform. And if everybody's going to be updated within like a month or 2, then what's the point, right? Like you're not going to be able to sell it to your customers fast enough in order to for them to be able to take advantage of it. And the last thing that you'll have to deal with is of course response issues. Once you become the target of attack, advanced persistent threats, you're obviously going to get more 0-day attacks against you. You're also going to get more researchers researching your platform, because now you're the new sexy thing that everybody is trying to find 0 days in. So once Flash Player started to become a popular 0-day attack, the number of responsibly disclosed issues, or coordinated disclosed, whichever term you prefer, issues also went up dramatically in terms of people who were trying to help out, trying to get us bugs and get a couple of CVE credits under their name. And so you need to be able to handle that sort of spike in responses. And one of the hardest things to deal with in terms of being able to get a response in time, decreasing your response time, is getting a response timeline goal. Like setting a goal seems like one of those mundane things, like, yeah, we should have a goal. Within Adobe, we set a goal of 14 days. That was sort of the goal that we had for responding to 0 days. And just sort of the act of setting that goal sort of changed the mindset, because then the developers had a challenge. And a lot of people get into development because they like challenges. They like the act of creation, they like solving hard problems. And since we set that goal, we've actually had some responses in as few as 2 or 3 days. But until we had actually set the goal, the mindset was, well, we can go one more day, we can go one more day. And what's one more day to really make sure this thing's solid and works? As soon as you actually set a goal and they have like a target in mind, you start to, what happens in the organization is that one more day mentality starts to fade away, right? Like they have a goal that they're shooting for. And the other thing is have a regular update schedule. Like one of the challenges you'll deal with is if your ship dates are always based on like features being complete, like it ships when it's done, then what happens is those backlog of reports just sort of sit there while you're waiting for those features to complete. Whereas if you work with groups for a regular update schedule, it makes it a lot easier to get those things out in time and try to keep responsibility disclosed timelines within 90 days or so. Another thing is always also provide tools for people. You know your product's better than a lot of other groups do. So one of the things I did is I wrote a tool called Swift Investigator, which is actually a tool that I use when I triage the 0 days. So a lot of the features in it are driven by the fact that I've had to take apart these Swifts and figure out, reverse engineer what they do and look at them at the assembly level and extract the binary payloads and stuff like that. So this is free. It's up on Labs. It's open source. You can extend it. You can do what you want with it. It's about 25,000 to 30,000 lines of code, somewhere in that ballpark. The GUI's not that great because I'm not a great GUI developer, but the engine is there. The technology is there. So if you're a Linux person and you're used to not so great GUIs, you'll probably be fine. So sort of in summary, if you're going to be attacked by these advanced persistent threats, you need to take time to understand them. You're going to need to start studying them are they learning? Where are they pulling their sources from? What can you learn about what they're doing to create a better defense? You're going to want to work on the holistic features. Like I said, with Reader, we did the holistic features. We were able to knock down the number of attacks such that PDF really isn't being 0 day anymore. Of course, now that I say that, there'll probably be one tomorrow. But at least it cut it down to the point where it was manageable. People don't have to update it quite as often. We're working at our schedule rather than the attacker's schedule in terms of improving security. Reach out and work with people. Like one of the things that sometimes frustrates me is at Adobe working with Flash Player, I'm sort of in the middle of things, right? Like I have to work with the Chrome security team for our integration with Chrome. I have to work with the IE security team within IE. I read the reports by Symantec and stuff like that. And there's a big push within our community for like independent research, right? Because you want to be independent. Because if you talk to the vendor, then the vendor's going to try and whitewash everything and make it sound like there's not a problem. If you talk to like the AV industries, they're going to want to blow up the threat so they can sell more product. And sort of like that cynicism sometimes prevents us from doing collaborative research and actually being able to produce stuff from collaborative. So independent's good, but you also want to be able to have collaborative research. And be willing to work with those outside groups and be able to talk with them. I'm on Twitter, I'm on Facebook, find me any way you can. And probably the most important thing is because the holistic mitigations take time to develop, like the Reader Sandbox took us over a year, you want to start early. You don't want to wait to see like, well, maybe it'll go away if we just sort of wait a while. They'll get bored and go away. And then the other important thing is to always keep moving forward. Just because the Reader attacks have gone down, we're still continuing to improve stuff. Because like I said, the attackers, they jump between platforms, right? Sometimes they're doing an IE exploit, sometimes they're doing a Java exploit, sometimes they're using a Swift exploit. They're technology agnostic. So just because Reader has gone down for now doesn't mean it's not going to come back. And so we need to be prepared when the circle comes back around, they start taking a look at Reader. So earlier this month, we just released the Reader 11 sandbox, which improves Reader security, the Reader sandbox. So in Reader 10, we weren't able to be on a separate desktop or a separate win station. With Reader 11, the new sandbox, we are on a separate win station, which separates us out even more in terms of sandboxing, so it's a much more improved sandbox. And also, we're moving forward with Win 8 and IE10 integration to be able to work with app containers and stuff like that. So with that, I don't know, do we have time for questions, or how are we doing?
We have about 1 minute left.
Okay.
So if anybody's got a really quick question.
Right.
We have one.
One over there. If you don't have time you can find me after the talk, and this is also all the different ways you can find us and talk to us about security.
So I'm wondering, how would you compare your response handling to Microsoft?
Microsoft's definitely fairly good. They've obviously pioneered a lot of the stuff that we've done, and we actually work with them a lot on our response through the map program and stuff like that. So I would hope that we're on par with what they're able to do, or at least in that ballpark in terms of 0 days. All right.
All right. Well, let's thank them.
Thank you, guys.